Me manda Maria. No do your homework? Nobody not hear me.
Hi, students. How are you doing today? Hello.
Afternoon, sir.
What's Arcana?
Sir?
This is what is happening. That's why I couldn't come on early. So I don't know what is happening. Is anybody hearing me?
Yes, sir.
All right. I mean, I'll say that I want anybody to just help me out. So the we call it now. The touchpad can go bad on a computer, right? I guess the answer is yes. Is there a troubleshoot that I can do to reset it?
Now that I've heard of.
So, there is a Jamal McLean whose name appear above my name in the in the um in the list. As I need to click on my one, something came up, and I am here. So I was having some difficulties getting on, and I'm here trying to do some stuff, and then it just freeze on me, and I don't even know if I'm coming across even clear as we speak here. What can I do? Should I shut the system down and restart it? Tell me what to do, because it playing some jokey jam thing. What should I do?
Oh, yes, sir. If it's not a hardware issue or the touchpad is physically damaged, then restarting usually helps, or reinstalling the drivers. But restarting should be the first option.
All right, thank you, Riton. So I'm going to log off now and then come back. No, hold on. Let me see if I can just switch to my phone so that I don't lose a comment. All right. So I just switched my phone. I'm just giving enough time for the computer to restart. In the interim, let me just ask, how is it going? Are you okay, feeling comfortable with the Newton Rapson? Difficulties you're having? Is there any difficulty? I need to know what it is because I'm moving on as I told you tonight. God's willing.
No, sir. I'm good.
You're good. Nice.
Feel
Anybody else?
comfortable with.
Sorry, say that again.
Saying I feel comfortable with it.
I feel comfortable. Nice. The rest of you talk to me. And just be very honest with me because I mean I'm trying to help you. So just be very honest. If you're not feeling comfortable, nobody in the class don't have the right to think of you otherwise. I just need to know while this thing still is booting. Is there nobody in the class having a difficulty with what is happening? If so, you need to say something so that I can see how it is that I can maybe meet you or whatever else the situation is.
It's
So I
okay
heard from
for, it's
am I
okay
to
for me.
understand that the silence mean let me tell you something. I'm asking the question now. I don't want it to later and say, oh sorry, can I go over? I'm not going to do that because semester is running. I have to move into my differentiation review today so that I can move into the McLaren's stuff. All right. Since I won't belabor the point, there are 13 of you here. I heard from about 3 students. The rest of you are fine. All right, let me see if I can now switch back over to the computer, please. Give me a minute.
Sir.
Yes, Alvin.
It was implicit differentiation. You said it's supposed to recap on, right?
No, not implicit. We're going to be looking at the exponential and the logarithmic forms of differentiation as a recap.
But which? Oh,
The implicit one, yes, will be done, but not just yet. I don't ready to touch stationary points yet. I'm trying to
Oh.
build a little bit first before I move into stationary points where we're going to go into those implicit differentiation. And the type of differentiation that we're going to be doing is really multivariable function, right? At some point in time, you were introduced to x and y together in an equation in calculus 1. In calculus 2, I am going to be introducing you to not only x and y, but x, y, and z. All right,
Oh.
so you're going to get x, y, and z together to work with, right? But we don't ready for that yet. I don't want to stress you out. Go ahead.
Because the implicit differentiation may recap on the
And
algorithm.
that's fine. And that's fine. You will be fine. The information will be lost because we're going to be using it at some point in time. So
All
if you
right,
can
sir.
look, in the meantime, as I'm trying to set up now, if you can go to the if you can look over the exponential and the logarithmic. I know I did those with you. That's what we're going to spend a couple of minutes and then I must move into Newton Raphson. The system is coming up, right? Give me 2 seconds.
Okay, sir.
Um, Hello, Mr. Mark. Oh,
Give me 2 seconds, Crosswell, please. 2 seconds.
no, I thought this said calculus one. That's why I came in.
Yeah, man, don't mind if it says calculus 1. No, it didn't say calculus 1, it says calculus 2 actually. But all of this is a review of what we did in Cal 1. And this is just a quick review so that we can get ready for the new area to come. All right. Sorry. Something just jumped out at me. Tiffany Andrews?
Yes, sir. I thought this was a different class. I'm not supposed to be here.
No, man, stay. We want you to stay. Stay, man. Stay and learn some maths.
Oh, sir, stay. I can stay.
Which maths you supposed to be doing?
Oh, sir, I have just passed discrete maths. I haven't done probability yet, but I also haven't done calculus on it.
All right, never mind. So you can come back next year then. All right, Tiff?
Yes, sir.
Big up yourself. All right, let me just check the okay. All right, I think we are okay, so we're on familiar grounds. Okay, so a very quick review on what it is that we did some time ago is when I'm differentiating an exponential function. What is the differential of an exponential function? Anybody remembers? The differential of an exponential function is?
I remember. I can't remind us, please.
It's the function itself.
Very good, very good, very good, very good. I can understand, Tariq, if you don't remember. But yes, the function itself. All right. So when I'm differentiating the exponential function, it is going to be the function itself, but I'm also going to be differentiating the function and use that as a product. So what I'm saying to you is e to the first power, e to the first power, or e to the x, e to the x. The differential of e to the x is e to the x. But guess what? You recognize the power, what the power is equals to, the power is equals to x. When I differentiate x, I'm going to get 1. So I'm going to multiply that by the derivative of the function. It's going to be multiplied by the derivative of the function. Let us move to e to the 2x. Differential of e to the 2x is e to the 2x. See here? E to the 2x. However, I must differentiate 2x and multiply that by the e to the 2x. See here? So it's 2e to the 2x. Let me be creative. What is the differential of e to the 3x? The differential of e to the x is e to the x. But I also now need to multiply it by the differential of the power and the differential of the power is going to be 3, so it becomes 3e to the 3x. If I'm differentiating y equals e to the x squared, the differential of e to the x squared is e to the x squared. See here, e to the x squared. However, I must also differentiate x squared and multiply the e to the x squared by it. So the differential of e to the x squared, nope, is going to be e to the x squared. But the differential of e to the of x squared is going to be 2x. So the answer now becomes 2x e to the x squared. See it right here. Let us look at this ugly looking one here. The differential of e to the 3x squared plus 5x minus 7 is e to the 3x squared plus 5x minus 7. However, we have to differentiate the power. And when we do that, we are going to end up with 3 times 2 is 6. We're going to end up with 6x plus 5. So my final answer is going to be 6x plus 5, the product, times e to the 3x squared plus 5x minus 7. Any questions?
No, sir, it's all coming back to me now.
Good job.
Yes, sir.
Sorry, what's somebody saying?
No, I'm saying it's also coming back to me, sir. Just
Right.
need to practice it.
So just remember, when I'm differentiating the exponential function, it is going to be the exponential function itself. But I'm going to be differentiating the power of the function and use it as a product of the exponential function. All right? So there's nothing much really to that.
So, sir.
Yes, Papa.
So, what if you put the differential of the exponential in front of the function? Would it still be correct?
If you put the what?
For example, number 5, you arrive at the function and put the 6x plus 5 after the function.
No, not gonna look so cute at all. Not
All
gonna
right.
look so cute. Yeah. All right. So therefore, this is going to support the point that the differential of e to the x is e to the x. But we have to do something else, right? So we're going to the differentiated power times the exponential function, right? So we're going to differentiate the power and then times it by the exponential function. All right, let us look at an example. Let us look at an example. And I'm going to put the example in its entirety on screen. Putting the example entirety on screen. And just to remind you, the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. That's what we use to differentiate a quotient. Quotient. Watch me. The differential of e to the x squared over x plus 5 is e to the x squared over x plus 5. Now, Alwyn, you asked me a question just now, and I said no. And then you're going to say to me, but sir, at the same time, I just asked you about right here, so. And again, I don't know if you recognize that when I answered you, I paused, but I said nothing more. So as soon give you the reason I said no to this question here. Matter of fact, let me give you now. I would much rather if you put the 6x plus 5 in front of and in parentheses. There are oftentimes students will leave out the parentheses and just put 6x plus 5 e to the 3x squared plus 5x minus 7. That is a different answer than what I have on board. Because what I have is 6x plus 5 times e to the 3x squared plus 5x minus 7. Oftentimes I see students leave out the parentheses and just put 6x plus 5 and then put e to the 3x squared plus 5x minus 7. What that is saying is 6x plus 5 times e to the 3x squared plus 5x minus 7. Can you see that?
Yes, sir.
Mm-hmm. So that's why I hesitated when I answered you at first, because I'm seeing it happen one too many times, right? So when I said to students, put it in parentheses, don't put it at the end. It's a lot of things. So you'll see me when I'm doing some of them going forward, and you'll see how it is that I'm representing them. Your parentheses, your brackets are very important at this stage, colleagues, students. Very, very important. It makes a big difference. How it is that you read this stuff, it makes a big difference. Big, big difference. All right, so let's go. And I want you to watch what I'm doing right here. So we are differentiating here. So y is equals to e raised to the x squared over x plus 5. I'm differentiating the power. Remember, now the differential of e to the x is e to the x. So what it is that I'm now doing is differentiating the power. The denominator, which is x plus 5, c here, so x plus 5, times the differentiation of the numerator. When I differentiate x squared, I'm going to get 2x, c right here, so, minus the numerator, minus x squared, c here, so, times the differentiation of the denominator. When I differentiate x plus 5, the differential of x is 1, differential of positive 5 is 0, so I'm just going to have 1, c right here, so, all over the denominator squared, all over x plus 5 all squared. So this is what it is right here. I'm just going to fix it up now. 2x times x is 2x squared, see it right here, so. 2x times 5 is 10x, see it right here, so. And negative x squared times 1 is negative x squared, all over 5, x plus 5 all squared. Now you will remember me saying to you that when you're doing the differentiation of a quotient, never go ahead and expand the denominator. Never ever try doing that. Don't expand the denominator. It's not going to take you anywhere. It's like you're going around a roundabout and continue going around a roundabout. You're driving, but you're driving in oblivion. You don't know, you have nowhere going. All right. And then I'm going to just fix up my numerator. 2x squared minus x squared is 1x squared, or just x squared plus 10x. And if I want, I can factor out a x, and I leave it right here. But you notice every single time I'm still carrying back this. This is not supposed to be there. So forget about this piece. I don't know why I have it there. It's not supposed to be here. I have my e to the x. I still have my question right here, because the differential of e to the x is e to the x. But I also have to differentiate the function. Now, this is very, very important in doing this stuff. Are you okay right here?
Run back on top again, sir.
The denominator
Yeah.
times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator.
Hold on, sir. You're breaking up.
Am I? Hold on.
Yeah, not hearing you.
All right.
All right, hearing you now.
Okay. I haven't moved, but anyhow, the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. All over the denominator squared. So what we're doing is to differentiate the quotient here. So the denominator, x plus 5 times the differentiation of the numerator, x squared, which is going to give me 2x, minus the numerator, minus x squared, times the differentiation of the denominator. When I differentiate the denominator, I'm going to get 1. See the 1 here. All over the denominator squared, all over x plus 5 squared. Remembering that we never normally expand the denominator. We leave it as it is. Now, all I'm doing is just to simplify the numerator.
Yes, sir. We get it now, man. What did that throw me off? Did I look on the denominator squared? So that threw me off when I get the
Okay, got
The
you.
one, yeah, so that threw me off. So I never see the function never squared in the beginning.
Got you. All right. So I have a do now for you. It says y is equal to all of this. Remember the rule? This is a product. So it's a first times the differential of the second plus the second times the differential of the first. So I want you to give this a try for me, please. Remembering, when you're differentiating the exponential function, it is going to be the exponential function times the differential of the function, the power. Give that a try for me and let me see how you remember this. And then if you do, maybe I give you one more, and then we'll move into the logarithmic function so we can move into the Maclaurin's.
Sir, can I check it out, please?
What said it again? Aaron, what do you want me to do?
Check the chat.
Oh, sorry, chat, yes. Okay, checking. All right, ask to respond. I see. I see your, yeah, man. So that is not incorrect, but fix it up, no, man. Yeah, put the vegetable one side, man, and the meat one side, and the gravy upon the meat, and nobody put it on the rice. So based on the check that I've done just now, it is correct, but you can fix it up a little bit, man. So it's not wrong, but fix it up.
All right, sir.
Good job. Anybody else? All right, so return, it will be the same thing that I said to you, return. Both you and Alwyn. Big up yourself, Ashanti. This is what I want to see the answer, the final answer to be. So very good, Ashanti. You've reduced it to what I'm expecting. Very nice. So Rayton, you're not correct, you're not incorrect, but it has some way to go in order to get to the final answer.
All right, sir.
Congrats, Ashanti. Keep them coming.
check the shot again, sir.
So you can tell me if my answer is anywhere near or if it's very far.
All right, Tariq. So maybe you weren't listening to me in terms of the parentheses, the use of the parentheses. So you need to, I don't know if you have it in your book, but didn't put it, type it for me. We still have another step to go, Alwin.
Let me check it out.
All right, let me go. I'm gonna go. I'm seeing some people struggling. Some people are struggling. I don't want you to be struggling. All right, so this is it. It's the first times the differential of the second plus the second times the differential of the first. It's the first to x minus 4 times the differentiation of the second. When I differentiate the exponential function, I get the exponential function itself. So see, I write it back here exactly as it is. And then I'm going to differentiate the power. When I differentiate 7x plus 1, I'm going to get 7. See here, times 7. Times 7. Plus the second. So I'm going to add the exponential function again, which is e to the 7x plus 1 times the differential of the first. When I differentiate the first, differential of 2x minus 4 is 2. So this 2 is here. So most of you gave me this line, not necessarily in this order, but I got this line. What I would have done here now is just to fix up the something by taking out the multiplication signs and just using my pure brackets, which is what I did here. And then this 2 run here, so now I'm going to put it in front of the sub right here, so. And the 7 run at the back run here, so I'm going to carry it and put it at the front right here, so see it here, so. So this line here is my fix up line. And then now I recognize that, yo, e to the 7x plus 1 is common to both. So I can factor out the e to the 7x plus 1. When I factor out the e to the 7x plus 1, what is going to be left? Is going to be 7 times 2x minus 4 in the first part of the question. And then what is going to be left when I take out this?
My last.
All right. Say nothing more. Can somebody read the question for me, please?
Y is equal to open brackets 2x minus 4, close brackets e to the 7x plus 1.
So dy by dx is going to be equal to the first times the differentiation of the second. The differentiation of the second. Differential of e to the x is e to the x. So then have e to the 7x plus 1 times the differential of the power. And only times it by the differential of this power, which is going to be 7. That's finished. Plus the second times the differentiation first. And I differentiate the first. The differential of 2x is going to be equal to 2. And I differentiate that is going to get 0. So minus 4 equals to 0. Now, differentiation ends there. I'm fixing it up. dy by dx is going to be equal to, I'm taking this 7 and I'm carrying it in front of the 2x minus 4 e to the 7x plus 1 plus taking that 2 and carrying it in front of the e to the 7x plus 1. Follow so far?
No, sir.
Let's say what I can. I mean, I don't know.
Because based on the rules, let me say underneath the question, that now look like we have after write a dy by dx, the first one.
What was the rule you saw under the question?
The first times the differential of the second plus the second times the differential of the first.
The first, is this a first?
Yes, sir.
And I'm now differentiating the second, all right? Differentiate the second with me now. What do I do?
I thought it's supposed to put the 7x plus 1 in front of the e. And then put back the 7x plus 1 in front of the e again.
Was that what I was doing all along? Was that what I was doing all along? Or was I differentiating up here first? Talk to me, class. What was I doing?
Differentiating the power and then multiplying it by e.
Right, I was differentiating the power and then multiplying by the exponential function. Differentiating the power and then I'm multiplying by the exponential function. To show you what it is that we're doing. Therefore, it supports the point that the differential of e to the x is e to the x. So we can clearly see that the answer is the differentiated power times the given exponential function. So if you look at this question, I'm differentiating the power. Differential of 3x squared plus 5x minus 7 is going to be 6x plus 5. So it's the differentiated power times the given exponential function. So I differentiate the power and then multiply by the exponential function that was given.
Okay, sir.
All right, okay, if you're not seeing it, are you seeing it? So then, okay, that is not making me okay. So if you're seeing it, but you're understanding what it is that you're seeing.
Yes, sir. Can continue, sir.
Is there anyone else in the class that is not seeing it? That's right. Questions. Are you following me? Are you understanding in the questions?
No, follow.
All right, so let's start again. Keep the questions coming, guys, please. Make sense in the class and understand what sir is doing. All right, so let's continue. So all I'm doing now, I recognize that there is something common. I recognize that e, the 7x plus 1 is common here. And it is also common here. So since common, we can factor it out. So dy by dx is going to be equals to e to the 7x plus 1. It's common. I'm factoring it out. I don't want it because it's common. Then when I take out that one, what I'm going to be left with is 7 times 2x minus. When I take out the e to the 7x plus 1 from this side, what am I going to be left with?
Sir, 2 plus 2.
The dy by dx. What is 7? I'm distributing this 7 over the x minus 4. 7 times 2x is?
14x.
Good job. And 7 times -4 is?
28.
Negative
Negative.
28.
Plus 2. So that is going to give me 14x minus 26, don't it?
Yes, it does.
All right. So and what I'm going to have here now is
26.
e to this
Oh, yeah.
e to the 7x plus 1 times 14x minus 26. My preference is to say 14x minus 26 e 7x plus 1. Question?
Sir, I never go through all of this.
Another question.
Sir, it seems there's an issue with your mic, sir, because I hardly hear you.
Something you're doing is at 100.
Same thing. I can tell that you're speaking, sir, but I cannot hear you clearly.
There was here when you say it's at 100.
Oh, let me try and external. Are you hearing me better now?
Yes,
Yes,
sir.
sir. 100% better.
Okay. All righty. Okay. Ashanti, I was asking you, what did you do differently?
First, I differentiated each of them. So when I differentiated 2x minus 4, I got 2. And when I did the exponential one, I got 7e exponential 7x plus 1. then it's the first differential times the second plus the first times the differential of the second. That's what I did.
Well, actually, the second times the first, so the second part of what we just said a while ago. So the first time the second was the second times the first.
Mhm.
Said the same. You said the same thing twice. But technically, it's the same thing that I did.
The first times the second.
Plus the second times the first.
Sir, I know that I have, to be very honest. I have differential 2 times E7x plus 1 plus 2x minus 4 times 7e 7x plus 1.
Same thing.
Oh, okay.
What you just said a while ago is exactly what I have. Is exactly what I have in this line. It's exactly what I have in this line now. All I'm doing now is to present the, put it this way, Ashanti. And I want you to answer me, because the man in the class can't do it. If you are preparing chicken and rice and vegetable and juice, how are you going to decorate the plate? How are you going to plate the food?
Come again, sir?
Ashanti, you can't cook, you can't cook, you can't cook.
Sir,
If I said to you,
after a while ago, sir.
Very disrespectful.
Ashanti can't cook. Come on,
Sir,
Ashanti, don't.
you.
All right, you know, all right, I forgive you. All right, so you're cooking chicken and rice and vegetable and juice. How are you going to plate the food?
You're not going to put everything in one plate?
Sir.
Yeah,
Tell us,
how you going to do it?
Sir, tell us, if you only can't cook.
Yeah. You're showing up yourself. But anyhow, so the point I'm making is, you know, presentation is also very important. So you can put the rice one side, you can put the chicken one side, and the vegetable one side. You're not going to share it like what the man in the shop share it. You want heap of rice and then fling the meat on top and then eat up the vegetable to one side. No, because we eat with our eyes first, and then know everything else thereafter, because it has to be presentable. So what I'm saying to you, the differentiation ends right here, but it is not presentable. I have to know, this is me putting the vegetable in the rice and I mix up the vegetable and the rice and then finger on the meat somewhere else. And somebody may say, but sir, when it goes down, that's exactly how it's going to look. I agree. But you have to first, it has to first attract you so that it can actually go down. So what I'm saying to you, Ashanti, is I am looking to see what is common, because what you gave me is exactly in this second dy by dx line. I'm looking now to see that the e to the 7x plus 1 and the e to the 7x plus 1 are the same. So I'm factoring it out. I'm factoring it out. When I factor it out, I'm going to see what is left. When I take off this one, what is left is going to be 7 times 2x minus 4. 7 times 2x minus 4. When I take out this one, what is going to be left is going to be 2. See here? 2. And then them something here now, a common something, so I'm going to deal with them. I'm going to deal with them. So I just distribute this 7 over this 2x minus 4, and I'm going to get 14x minus 28. And then I'm going to add this 2 that stands alone with it. Now the 14x is going to remain because there's no other x in the function, x term in the function. So I'm now going to be adding negative 28 to positive 2, and that is going to give me negative 26. Is that more here? No?
Oh, yes, sir. I am.
Why are you so silent, sir? You're multitasking. You're multitasking. Sorry, never mind.
No, sir. I'm just tired today, sir. But me pay attention, sir.
All right, good job. And then now, what it is that I'm doing is having my 14x minus 26, based on the question that Alwyn asked, I can write it here with my e to the 7x plus 1. You notice I'm still putting it into parentheses, or I can put this 14x minus 26 in front of my e to the 7x plus 1. So it's presentation. This is presentation, man. The
first answer you get with the E7x plus 1, me da go put that, but me da remember you saying about, you know, when you answer them like that, You want the parentheses first before the exponential.
That's fine, man. That's fine. That's fine. Just make sure that you enclose it into parentheses. Yes, man. That's fine. All right. One more. I didn't expect this to take me this time, but never mind. As long as you are understanding, is my key. I really want you guys to be understanding. I'm giving you one more. Please let this one be quick and fast. There you go. Y equals 3x squared e to the x plus 1.
Check the chat, sir.
Okay, Rayton, I can't. Beat it on that. That is fine. Shade. Good. So Alvin, you put it in the form that I have it. Very good. Ashantia, very good. All right, very good, guys. All of them are correct. It's just Alvin that has it in the form that I have it. All right. Giving you 2 more minutes, guys. Come, Karno, I need to see yours, Karno. Taj, hey Taj, you're around for me tonight, you know? All right, very good, Tariq.
Sir, sir, could that be broken down more, or me kind of iffy about the answer, you know?
For which one? For your answer?
Yes, sir. Or that's it.
You'll see, that's fine. I mean, I would have given you full marks for this. So far it's just Alvin that has it in my format. But that's
Oh,
fine. I will give you full marks for it.
okay,
All right,
sure.
2 more minutes, 2 more minutes, 2 more minutes.
Sir?
So disconnect here. I'm not seeing any other. Oh, sorry. I was just about to ask. It's interesting. All right. So very good. All right. So Fahim, yes, you have it in the format that I have it. Yes, the more. Look at what I have on screen.
Oh, man, I wonder if we go further, no, sir. Because me have lot from people, but me never know if we go further or not.
So things that we can factorize, just go ahead and just factorize.
Oh, me never know that.
But as I said before, right? But as I said before, I wouldn't have penalized you. As you get a little bit more mature mathematically in the course, you'll see what is happening. All right. So my plans for today kind of change somewhat, but never mind. Race is not for the swift, but I just make sure I need for you guys to understand what is happening. Anyhow, I'm gonna press pause right there, and I'm gonna be going through the logarithm function. I have only half an hour left in the class. So the differentiation of the natural logarithmic function, ln x. The differential of the natural logarithmic function, ln x. So the differential of that function is going to be 1 over the function times the differential of the function itself. Sir, I don't understand what you just said, and that's fine. When you read it one more time and you still don't understand it, still fine. When we are doing it, you'll see what it is that I'm talking about. And then I'm going to reread this stuff for you, and then you will see it. The differential of the logarithmic function is 1 over the function times the differential of the function itself. This is just my way of saying it. You're not going to find what I have. My notes, you won't find in the text. This is me simplifying the stuff so that my students can understand what's happening. Right? Pretty much I'm just summarizing what it is for you. Let us look at what it is that we have here. Y equals ln x. The differential of ln x is 1 over x. 1 over the function. Function is x. Then, sir, why anybody does say x and done? Because the function will not always be x. Just like we have e to the x, and it's not always x. Sometimes it's 3x squared minus 7x plus 1. Yeah. So that's why I said the function. Function is not static. It moves. It can change. Right. Times the differential of the function. So I no need to differentiate x. When I differentiate x, I get 1. See the 1 right here, so? So therefore, I'm going to have 1 times 1 over x is just simply 1 over x. So when I differentiate the logarithmic function, once I see ln and the function is a logarithmic function. And I'm just going to put 1 over the function itself, but I must remember to differentiate the function. Let us look at this. Y equals ln x squared. So it's different because this one now is x squared. The one before was just x. 2. Right? So look at what I'm going to be doing. I'm going to be saying 1 over x squared. Why, sir? It's 1 over the function. Function now is x squared. So it's 1 over x squared times the differential of the function. When I differentiate x squared, I get what?
2x.
X is going to be times 2x. So see here, 1 over x squared times 2x. 1 over x squared, 1 over the function times the differential of the function. When I differentiate x squared, I'm going to get 2x. Boom. I'm going to fix it up. 2x times 1 is 2x over x squared. Watch this. The x here cancels with 1 of the x here. So we have 2 over x. So 2 over x is going to be my answer. Following so far?
Yes, sir.
Yes, sir.
So this one here now is a format that them love to give you in now. When we're going to move into Maclaren's. Them love give it in this format now.
Move into what, sir?
Maclaren's expansion. Maclaren series, that's the next topic. I'm only doing this to Maclaren's. So we'll finish with Newton-Raphson. So moving to another one now, Maclaren's. All of what we're doing in Calculus 2 are all applications to what we learned in Calculus 1. All right. So now, we are differentiating ln x plus 1. Can you see that the function changes? This one is just x. This one is x squared. Rockstone. This one now moves to x plus 1. So the only thing that is constant here is going to be the ln and the ln and the ln. So these things change. That's why I say 1 over the function. So if I'm differentiating ln x plus 1, it's going to be 1 over the function. 1 over x plus 1. And then I'm going to times it by the differential of x plus 1. What is the differential of x plus 1?
So that's one.
Oh, teacher, 1 over x plus 1 times the differential of 1 and says that. Right. You don't understand this because some of you did very well for the calculus one. Telling you. Some of you did very well. So I know there are students in the class that are following. There are students in the class that may be struggling, but I know there are a few students in the class that are following. I'm giving you 3 minutes. I'm generous. I'm giving you 3 minutes to do this question for me. Quick and fast.
Is that right? I'm saying in chat. And we need to look back and try again.
Well, all I can tell you is that I love the effort. I really do love the effort. And
Will and come again?
it is, you did something, but you never, you almost got it. When I say almost, so very close. But there's something that you needed to. Derek,
Factoring.
one go look on this one. One go look on this one. One
Alright,
simple.
I'll go back.
Yeah, man. I'm seeing some answers coming in to me that I'm responding to that. And also certainly some of the non-negative responses. I know I'm very aware of that. What happened to me? But if the same circumstances, exactly as the person is about, Mr. Shah never teach you. Yes, good. So I've responded to your messages, please. Let's look at what is asked of us. Let's set it up. Or it is that you're multitasking. It is seeming difficult. The question says, Ellen. The question I gave you.
ln parentheses 2x plus 1 parentheses close parentheses cube.
Thank you. See it here, so the methodology says you're going to put 1 over the function. You're putting 1 over the function. So I can put 1 over 2x plus 1 cube. See it here, so 1 over 2x plus 1 cube. And then I'm going to differentiate the function. When I differentiate the function, what rule is this one, guys?
Or
Rule, right? The
that's the
power
power
rule.
rule, sir.
Yes, I.
Sir, the squared, sir.
So I realize. So I realize. All right, now. And then what is going to happen is it's a power rule. So this 3 is going to multiply in front of here. See it right here, so? And then I'm going to write back my 2x plus 1 and reduce it by 1. So I'm going to write 2. But I now have to differentiate what is on the inside, which is going to be 2. So 2 times 3 is going to give me 6. So I'm going to have 6 times 2x plus 1 all squared, see here, all over 2x plus 1 cube. What I did to show you is that 2x plus 1 cube is the same thing as 2x plus 1 times 2x plus 1 squared. And the 2x plus 1 squared cancel out. So all I'm going to be left with is 6 over 2x plus 1. That's my answer. I know you know it, you know. I taught the calculus once. I know you know it. I know you know it. It's because of the mistakes that you're making. I'm going to give you one that don't so huge at all. Final one before I introduce in about 10 minutes, 15 minutes even, mathematics. Just to introduce it. Number 5, I'm giving you 4 minutes with that one, please. Take your time, look at the stuff properly, follow the methodology, you'll be fine.
Sir, please check the chat.
Alwyn, you very close. You make a one mistake. And I'm almost positive that you have it in your book. Look back in the book and look what you typed, and then come back to me again. Thank you, Ashanti. You go proceed. Oh, you get your free. Thank you, Demo. You go proceed. Check the numerator corner. Exactly. Good job.
Repeat that, sir.
Check the numerator corner. For the most part, very well. I'm pleased.
Yes, sir. So check the numerator.
Yeah, check your numerator. Or you can also check what I have here, -5. So what it is that you have here is I'm trying. So I realize, right, let me just go ahead and look at. So we have y equals ln x2 minus 5 all squared. The rule says once I have an ln function, it's 1 over the function. Write back everything. 1 over everything we didn't give. See there? 1 over x2 minus 5 all squared. Then we need to differentiate this. Again, this is a power rule, so it's going to be 2 times x cubed minus 5, and you reduce it by 1 to the first power. but you now have to differentiate what is on the inside of the parentheses. So when you're differentiating 3x squared, 3x minus 5, the minus 5 when you differentiate is a constant, it goes to 0. But you also going to be differentiating x cubed. When you differentiate x cubed, you're going to get 3x squared, which is this. So all you need to know is everything here is a multiplication. So you're just combining all of them. 2 times 3 is 6. So we're going to have 6x squared times x cubed minus 5. See to yourself. All over this. And when I put it over there now, what I did here was to break up the x cubed minus 5 all squared into x cubed minus 5 times x cubed minus 5. So you see clearly that the pair of these will cancel, leaving only one. So I'm going to have 6x squared over x cubed minus 5. So people giving me 6x, they're leaving off the square. Same way, so can't leave off the square, make a big difference. All right, so we know we're making a little bit of mistakes here and there, but are you feeling a little bit more comfortable now with the refresher of the exponential and logarithmic functions?
Yes, sir.
Yes, sir. Let me stay there.
Yes, sir.
Good. All right. I want you to write this off. I want you to write off these two formulations because I'm going to ask you to study these two formulations over the weekend. Write it off for me, please. You don't need more than a minute to write. Now, deliberately say write and not screenshot. Even if you screenshot it, I want you to write it. Writing makes a big difference. So I'm teaching this class online, virtually. So I have to do things. You notice when I was doing a question about that, trying to say, no, sir, my loss. No hard feelings. I dropped what I was doing and I grabbed from my writing device. Have to write.
Sir, for the first equation, is it Fn or is it f to the second differentiation and then f to the third?
You see, I was going to ask, where are you in? Because I never see you last class, enough, Chrissy. But I'm glad it's coming.
It's a miracle I'm here today. I reach
I'm
home late
happy.
these days. Because of the
Never mind.
Valencia Spanish town, they send us home early. So I'm here.
Hush. All right.
So is it f to the second differentiation or is it fn?
The second.
And the next one is the third?
Then the last one is f to the n. So what it is saying is, for the Maclaurin's theorem, what it is saying is f of x is going to be equals to f of 0. Watch what I'm doing. I'm just going to explain what it is. I don't think I have enough time to do a question, but I just want to explain the formulation. It's going to be 9J. 9J. It's not 9J. Yes, I'm not seeing Mason. I'm not seeing 9J either. So f of 0. So when I'm doing the function, it's going to be f of 0. It means that the original function that is given, I'm going to substitute 0 in the function. Wherever in the function I see x, I'm going to substitute 0. The answer that I get is going to be right here. So plus f dash of 0 of x. F dash of 0 of x. It means that I'm going to find the differential, the first differential of the function, which is going to be f dash of x. And anywhere in that function, I see x. I am going to put in 0. Then, and this one on here, we say that I'm dividing by 1 factorial. But you may not see anything under here because 0 factorial and 1 factorial equals 1. So that's why I asked you to take note. So this and this exactly are the same things, you know. It's just that you're seeing 2 factorial, 3 factorial, 4, and so on. But you're not seeing anything under here. This is going to be 0 factorial. 1 factorial. Oh, sir. That means since you don't take the derivative of it, it's going to be 0. R2. And because this is the first differential, so we're going to have 1 factorial R2. Sure, I see it now. It's 2 factorial because it's a second derivative. It's 3 factorial because it's a third derivative. It is n factorial because it's the nth derivative. Yes. So you need to see these patterns. Any question?
Sir, how do we know when to stop?
The question will, sometimes the question will stop on its own. Remember the last class I said to you that we look at the function with infinite series. So infinite series means that it go along. You don't have no end in sight. But the question will be worded to say up to and including the term in x to the 5th. So therefore, you know, so you can stop at x to the 5th. Follow me?
Yes, sir.
And if you are given a finite series, we're not going to tell you where to stop because you're going to know where to stop because at some point in time, when you differentiate the function, you can get 0 because that is finite. But if it's an infinite series, I have to tell you up to and including the term in x to the 3rd. It means you're going to stop at x to the 3rd.
Sir, can you a question?
Sir, I'm not sure if you had explained it, but what's the purpose of the exclamation mark in the denominator?
Oh, yes, it's my pre-calculus class that all right, so actually I won't go to the question again. I didn't project the factorial notation because I thought I did it with you, but no, it's my pre-calculus student that I did the factorial notation with. All right, grab your calculators, please. So I'll end the class on this. I can do it in 3 minutes. Grab your calculators, please, all of you. Let me know when you have it.
I always did, sir.
So the explanation sign in mathematics means factorial. The exclamation sign in mathematics means factorial. So the exclamation sign in math means factorial. If you look on a calculator, you should be able to see the factorial sign. Quickly look at it and tell me if you find the factorial sign. Most calculators will be in the top left-hand corner.
All right, my dear, right, for x to the negative 1 is top of x.
Very good.
Yes, sir.
Good job. Mhm. Now, factorial notation. The factorial notation, if I'm asking for n factorial, it's going to be n factorial times n minus 1 factorial times. Well, again, n factorial is going to be n times n minus 1 times n minus 2 times n minus 3 times n minus 4, all the way down until I reach k. Sir, that don't mean nothing to me. Fair enough. It never did mean nothing to me when I was studying. So I understand. So that's why I've quickly given you this example of 5 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So 5 factorial is going to be 120. Use your calculator for me, please. Press 5, then press factorial.
Yes, sir. Get the answer, there, sir.
Yes, sir.
So that's what the factorial is. No, guess what? You don't have to go and say 5 times 4 times 3 times 2 times 1. You just can press 5 and the factorial sign, and it automatically calculates it for you. All right. So here goes a question. Here goes a question. You can take it off. You can give an attempt. You can maybe ask your YouTube channels to watch, or what you can do is go on to my other stuff, and you can look see if you can challenge yourself for this. I won't necessarily do this now, 7 o'clock. Ashanti, this is what it is that I'm saying. It says expand 1 over x plus 1. You know how to differentiate a rational function, because that's a quotient now. And it says up to and including the term x to the 5th. So it means that you're going to stop at the term x to the 5th. Follow me? No, yeah. So,
No, sir.
No, sir.
so what I'm saying to you is, I'm going to be naming the function. I'm just going to walk it through. I'm going to be naming the function. So it does tell me expand 1 over x plus 1. I'm going to name the function and call it f of x is equal to x plus 1. Remember, the formulation said that I need to put 0 in it. So anywhere in the function I see x, I put 0. So the first thing I'm going to do is to find f of 0. F of 0 is 1 over 0 plus 1, which is just 1. Talk true.
True, sir.
Yes, sir.
See it over here, so f of 0 is equal to 1. I'll put that down. Then the next thing I must find is the first derivative, and then substitute 0 into that. So I'm finding the first derivative. The denominator. Sorry. The denominator, x plus 1. See it here, so. Times the differentiation of the numerator times a constant is 0. Minus the numerator, minus 1. Times the differentiation of the denominator. When I differentiate the denominator, I'm going to get 1. All over the denominator squared. And then from that line, all of this goes to 0 because x plus 1 times 0 goes to 0. So I'm going to have negative 1 times 1 is just this negative 1 over my x plus 1 all squared. So this is my first derivative. And then I'm going to substitute 0 into it. F dash of 0, according to the formulation up here now. See here? F dash of 0. All of them when I differentiated, I'm going to substitute 0. F dash of 0. 0 plus 1 is 1. 1 squared is 1. Negative 1 over 1 is negative 1. and so forth and so on. If you find the second derivative, you have to go differentiate this one more time in order to find the second derivative. Fair enough?
Yes, sir.
A little bit.
If you don't catch this part of it, it's not a problem. No. What I want you to do is just look over it, and then for the weekend, just make sure say your angle and triangle the Newton-Raphson. Now we don't have any time to go over that one. Syllabus is long. So just make sure you understand the Newton-Raphson, and then now I will be able to, on Monday, God's willing, just to go through this one with you in more finer details. Having done the review on the exponential and logarithmic function. All right? All right, I'm gonna end here. Have a good one, guys. Take care. We'll see you next class. All the best, guys.
Yes, sir.
Same to you, sir.
Same to you, sir.